Look up at the night sky. See that reddish dot shining faintly? That's Mars, our planetary neighbor. For centuries we've gazed at it, wondering, could we one day call it home? The idea of living on Mars was once relegated to science fiction. Now, it's a real possibility, a challenge that humanity is actively pursuing. But what would it take to transform this cold, barren world into a second Earth? The journey to Mars is not just about physical distance. It's about overcoming immense scientific and technological hurdles. It's about pushing the boundaries of human ingenuity and daring to dream the impossible dream. But, as with any great endeavor, the rewards are potentially immeasurable. Imagine a future where humanity becomes a multi-planetary species, with a thriving civilization on Mars. Imagine the discoveries, the advancements, the new frontiers that await us on this alien world. The future of our species might very well depend on our success. Mars is a planet of stark beauty, but its allure belies a harsh reality. The Martian landscape, while captivating, is unforgiving. Temperatures plummet far below freezing, making Antarctica seem balmy in comparison. The atmosphere is thin, about 1% of Earth's, composed mostly of carbon dioxide. This means no breathable air for us humans. And then there's the radiation. Without a global magnetic field like Earth's, the surface of Mars is bombarded by harmful radiation from the sun and space. Water, essential for life as we know it, exists on Mars, but mostly as ice locked beneath the surface. The Martian soil, while potentially fertile, contains toxic elements that make it unsuitable for growing crops without significant treatment. Gravity, too, is a factor at only about 38% of Earth's. While this might sound fun at first, long-term exposure to low gravity can have detrimental effects on human health, including muscle and bone loss. These are just some of the challenges we face in our quest to make Mars habitable. Terraforming. It sounds like something straight out of a science fiction novel, but it's a real concept. It involves transforming the Martian environment to make it more Earth-like. Imagine thicker atmosphere, warmer temperatures, flowing rivers, and lush vegetation. That's the ultimate goal of terraforming. But how do we turn this vision into reality? It's a monumental task, requiring advanced technologies and a deep understanding of planetary science. One proposed method is to release greenhouse gases into the Martian atmosphere, trapping heat and causing a warming effect. Another idea involves using giant orbital mirrors to reflect sunlight onto the surface, melting ice and releasing trapped carbon dioxide. These are just a few of the ideas being explored, each with its own set of challenges and potential benefits. Why even attempt such a daunting task? Why not focus on solving problems here on Earth? The answer lies in the very essence of humanity, our innate desire to explore, to push the boundaries of knowledge, and to secure our future. Throughout history, we've ventured into the unknown, crossed oceans and scaled mountains. It's in our DNA. And now, the next frontier beckons Mars. Establishing a self-sustaining colony on Mars offers a safety net for humanity. It's a hedge against potential catastrophes on Earth, whether natural or man-made. Imagine a future where humanity is not confined to a single planet, but has spread its wings to another world. This is not just about survival, it's about growth, about expanding our horizons and ensuring the continuation of our species for generations to come. Section 5. Warming a frozen world. The heat is on. Let's talk about temperature. Mars is a frigid desert with an average surface temperature of about -63 degrees Celsius. That's about as cold as the coldest day in Antarctica. To make Mars livable, we need to warm it up significantly. But how do you heat an entire planet? One proposed method involves using orbital mirrors to reflect sunlight onto the Martian surface. These massive mirrors, strategically positioned in space, would act like giant magnifying glasses, focusing sunlight onto specific areas. This concentrated solar energy could melt ice, release trapped carbon dioxide, and gradually warm the atmosphere. Another idea is to introduce super greenhouse gases into the atmosphere. These gases, more potent than carbon dioxide, could trap heat and trigger a runaway greenhouse effect, leading to a warmer and more hospitable climate. Section 6. The gravity of the situation. Adapting to a lighter pole. Mars's gravity is about 38% that of Earth's. This means you'd weigh less on Mars, which might sound fun, but it poses significant challenges for human health. Prolonged exposure to low gravity can lead to muscle atrophy, bone loss, and cardiovascular problems. So how do we adapt? One solution is to create artificial gravity environments. This could involve spinning habitats or using centrifugal force to simulate Earth-like gravity. Another approach is to develop advanced medical technologies to counteract the negative effects of low gravity. This could include gene therapies, medications, or even bioengineered suits that provide resistance and support. Section 7. Water, water, everywhere. Unlocking Mars's frozen bounty. Water is the elixir of life, and thankfully, Mars has it in abundance, albeit mostly frozen beneath the surface. These vast reserves of water ice are a game changer for any future Martian civilization. But how do we access and utilize this frozen bounty? One method involves using microwaves or concentrated solar energy to melt the ice in situ, creating subsurface reservoirs of liquid water. This water could then be extracted and purified for drinking, irrigation, and other purposes. Another approach is to extract the ice directly and transport it to where it's needed. This could involve robotic miners, heated pipelines, or even specialized rovers equipped with ice-melting capabilities. Section 8. From red dust to green fields, cultivating Martian soil. The Martian soil, while rich in some minerals, is toxic to Earth life. It lacks essential nutrients and contains high levels of perchlorates, which are harmful to humans. So how do we transform this barren red dust into fertile ground capable of supporting plant life? One solution is to use bioremediation, employing microorganisms to break down perchlorates and other toxins, making the soil safe for cultivation. Another approach is to create enclosed hydroponic farms, where plants are grown in nutrient-rich water solutions, bypassing the need for soil altogether. These farms could be powered by solar energy and provide a sustainable source of food for Martian colonists. Section 9. The Pioneers of Tomorrow, Public and Private Collaboration. The journey to Mars is a monumental undertaking, one that requires the combined efforts of nations and private enterprises. Fortunately, we're seeing an unprecedented level of collaboration in space exploration. NASA, with its decades of experience and expertise, is leading the charge, developing cutting-edge technologies and conducting groundbreaking research. Private companies like SpaceX, Blue Origin, and others are also playing a crucial role, injecting innovation and cost-effectiveness into the space industry. This synergy between public and private sectors is essential for overcoming the challenges and realizing the dream of a human presence on Mars. Section 10. The Giant Leap Risks and Rewards of Interplanetary Travel. The journey to Mars is fraught with risks. The vast distances involved, the unforgiving environment of space, the psychological toll of long-duration missions, these are just a few of the challenges we face. But the potential rewards are immeasurable. Imagine standing on the surface of another planet, gazing up at a pink sky, knowing that you're among the first humans to set foot on this alien world. Imagine the scientific discoveries, the technological advancements, the expansion of human knowledge that awaits us on Mars. The risks are real, but so are the rewards. And as with any great endeavor, it's the courage to take that first step, that giant leap, that will define our future. Section 11. A Martian Legacy, Inspiring Generations to Come. The dream of a future on Mars is not just about escaping Earth's problems. It's about embracing a new frontier, pushing the boundaries of human ingenuity, and creating a legacy for generations to come. Imagine a future where children on Earth and Mars learn about each other's cultures, share their dreams, and collaborate on projects that benefit all humankind. Imagine a future where we've learned to live sustainably on another planet, where we've unlocked the secrets of the Martian past, and where we've paved the way for even grander adventures beyond the red horizon. The journey to Mars is a journey of hope, of inspiration, and of the enduring human spirit. It's a journey worth taking, not just for ourselves but for the future of our species and the countless generations yet to come. Can we create a second Earth? It's a question that has captivated humanity for generations. As we explore the cosmos, our neighbor Mars beckons with the possibility of becoming a new home for humankind. But transforming this cold, arid planet into a vibrant, life-sustaining world is a challenge of extraordinary proportions. While the task seems daunting, the dream of terraforming Mars, making it Earth-like, is no longer science fiction. Scientists and engineers around the world are actively researching and developing technologies that could turn this dream into reality. The year 2050 might seem close, but in the grand scheme of planetary timescales, it's just a blink of an eye. Transforming an entire planet is a monumental undertaking that will require generations of dedicated effort. Terraforming Mars is a multi-step process that involves altering the planet's environment to make it suitable for life as we know it. This means creating a breathable atmosphere, raising the temperature, and establishing a stable water cycle. Imagine vast Martian plains covered in lush vegetation, rivers flowing with liquid water, and a sky painted with clouds. This is the vision that drives the quest to terraform Mars. While the challenges are immense, the potential rewards are even greater. The first human missions to Mars are already in the planning stages with the goal of eventually establishing a permanent human presence. These early pioneers will lay the groundwork for future generations to transform the red planet into a second home. Before we can even think about terraforming Mars, we must understand the harsh realities of its current environment. Mars is a cold, dry planet with a thin atmosphere composed mostly of carbon dioxide. The average temperature is a frigid -63 degrees Celsius, or -81 degrees Fahrenheit, and the lack of a global magnetic field leaves the surface exposed to harmful radiation from the sun. Liquid water is scarce, locked away as ice beneath the surface or in the polar ice caps. The thin Martian atmosphere offers little protection from incoming meteoroids, meaning the surface is constantly bombarded by space debris. Dust storms, some of which can engulf the entire planet, are another hazard that future Martian colonists will have to contend with. While terraforming Mars might seem like a distant goal, there are steps we can take today to lay the groundwork for this monumental endeavor. One crucial step is to learn as much as possible about the Martian environment. Robotic missions like the Curiosity and Perseverance rovers are already exploring the Martian surface, collecting valuable data about the planet's geology, atmosphere, and potential resources. These missions are helping us to identify the most promising locations for future human settlements and to develop strategies for utilizing Martian resources. Another important step is to develop technologies that can be used to modify the Martian environment. This includes everything from advanced life support systems to machines that can extract water and other resources from the Martian soil. Section 5. Breathing life into Mars. The atmosphere puzzle. One of the biggest challenges of terraforming Mars is creating a breathable atmosphere. This is no small feat, as it involves transforming an environment that is currently inhospitable to human life into one that can support it. The current Martian atmosphere is incredibly thin and composed mostly of carbon dioxide, which is, well, toxic to humans. This means that without significant changes, humans would not be able to breathe on Mars. One proposed solution is to release greenhouse gases trapped in the Martian soil and polar ice caps. These gases, once released, could help to create a thicker atmosphere. These gases would trap heat from the sun, warming the planet and thickening the atmosphere. This process, known as the greenhouse effect, is similar to what happens on Earth, where greenhouse gases help to keep our planet warm. Another approach is to build giant orbital mirrors that would reflect sunlight onto the Martian surface, further increasing the temperature and potentially melting the polar ice caps. This would not only warm the planet, but also release additional gases trapped in the ice. While technologically challenging, this approach could significantly accelerate the terraforming process. The development of such advanced technology would require international collaboration and significant investment. Microscopic life forms could also play a role in terraforming. These tiny organisms have the potential to make a big impact on the Martian environment. Scientists are studying extremophiles, organisms that thrive in extreme environments on Earth, for their potential to survive and even flourish on Mars. These extremophiles could be introduced to the Martian environment to help kickstart the process of creating a more habitable atmosphere. These hardy microbes could help to convert Martian carbon dioxide into breathable oxygen and release trapped nutrients into the soil. This would not only make the air more breathable, but also enrich the soil, making it more suitable for growing plants in the future. The ultimate goal of these efforts is to create a self-sustaining environment on Mars where humans can live and thrive. This would involve not only creating a breathable atmosphere but also developing the infrastructure needed to support human life, such as habitats, food production systems, and water sources. Achieving this vision will require the combined efforts of scientists, engineers, and space agencies from around the world. It is a monumental task, but one that holds the promise of expanding human presence beyond Earth and opening up new possibilities for exploration and discovery. As we continue to explore and develop new technologies, the dream of breathing life into Mars becomes ever more achievable. The atmosphere puzzle is just one piece of the larger challenge of making Mars a new home for humanity. Section 6. The Search for Liquid Gold, Water on Mars. The quest to find and utilize water on Mars is one of the most critical challenges for future space exploration and colonization. Water is essential for life as we know it, and fortunately Mars does have water, albeit mostly in the form of ice. This ice is not just limited to the polar regions but is also found in various underground deposits scattered across the planet. Large deposits of water ice exist beneath the surface, and the polar ice caps contain vast quantities of frozen water. These ice caps are remnants of a time when Mars had a more Earth-like climate, and they hold the key to sustaining future human missions. Extracting this water and converting it to liquid form will be crucial for establishing a human presence on Mars. This process will involve advanced technology and innovative methods to ensure a steady supply of water. This could be achieved through a variety of methods, including drilling into subsurface ice deposits, which would require specialized equipment capable of operating in the harsh Martian environment. Melting ice using concentrated solar energy is another viable method. By harnessing the power of the sun, we can efficiently convert ice into liquid water, which can then be stored and used as needed, or even deploying swarms of miniature robots to collect and transport ice. These robots could work autonomously, gathering ice from various locations and bringing it to central processing facilities. Once we have access to a sustainable source of water, we can begin to create artificial lakes and oceans on Mars. These bodies of water would not only serve as reservoirs, but also play a crucial role in the planet's ecosystem. This would not only provide a vital resource for future Martian colonists, ensuring they have enough water for drinking, agriculture, and other needs, but also help to moderate the planet's temperature and create a more Earth-like environment. Over time, this could lead to the gradual terraforming of Mars, making it a more hospitable place for human life. Section 7. Gravity's Pull and the Shield of Life. While we can potentially address the challenges of atmosphere and water on Mars, two significant obstacles remain: gravity and radiation. These two factors are critical to the survival and well-being of any future Martian settlers. Mars's gravity is only about 38% that of Earth's, which could have long-term effects on human health. This reduced gravity environment can affect the human body in ways we are only beginning to understand. Prolonged exposure to low gravity can lead to muscle and bone loss, cardiovascular problems, and other health issues. Astronauts on the International Space Station experience similar issues, but the effects could be more pronounced on Mars due to the longer duration of missions. While the exact effects of Martian gravity on humans are still being studied, it's a challenge that we'll need to overcome if we want to establish a permanent human presence on Mars. Solutions may include advanced exercise regimes, medical interventions, or even artificial gravity habitats. Radiation is another major concern. The thin atmosphere of Mars offers little protection from cosmic rays and solar radiation. Unlike Earth, Mars lacks a global magnetic field to deflect harmful radiation from the sun. This means that Martian colonists would be exposed to significantly higher levels of radiation than on Earth, increasing their risk of cancer and other health problems. To mitigate this, scientists are exploring various solutions, such as building habitats underground or using advanced materials to shield against radiation. These measures are crucial for ensuring the safety and longevity of human life on Mars. The journey to making Mars a second home is fraught with challenges, but with innovation and determination, we can overcome these obstacles. Section 8, Mars 2050, a realistic timeline? Given the immense challenges involved, is it realistic to think we could terraform Mars by 2050? The short answer is probably not. Transforming an entire planet is a multi-generational project that will likely take centuries if not millennia to complete. However, that doesn't mean we can't make significant progress by 2050. By that time, we could potentially have established a permanent human presence on Mars, laid the groundwork for terraforming efforts, and even begun to see the first signs of a changing Martian environment. The journey of 1,000 miles begins with a single step. While terraforming Mars by 2050 might be overly ambitious, the steps we take today will pave the way for future generations to inherit a new world. Section 9. Onward to the Red Frontier. The quest to terraform Mars is a testament to the boundless potential of human ingenuity and our enduring fascination with the cosmos. While challenges abound, the potential rewards are too great to ignore. Imagine a future where humanity is no longer confined to Earth but has spread out to inhabit multiple worlds. Terraforming Mars is not just about creating a second home for our species. It's about pushing the boundaries of what's possible and ensuring the long-term survival of life as we know it. The journey to Mars will be long and arduous, but the destination, a new world filled with promise and potential, makes it a journey worth taking. Onward to the Red Frontier. Imagine looking up at the night sky, knowing that Mars, the red planet, is not just a distant neighbor but a thriving second home. With rapid advancements in technology and a deeper understanding of planetary science, this ambitious goal no longer seems entirely out of reach. Mars, with its cold, barren landscape, presents numerous challenges for human habitation, yet the potential rewards are immense. Establishing a human presence on Mars could ensure the survival of our species, inspire new generations of explorers, and push the boundaries of our scientific knowledge. The question remains, how can we turn this vision into reality within the next 55 years? This essay delves into the steps necessary to terraform Mars, transforming it from an inhospitable environment into a new home for humanity. Let's embark on this journey together, exploring the first steps of terraforming Mars and envisioning the future of humanity on the red planet. Terraforming, the process of transforming a hostile environment into one suitable for human life, has long been a fixture of science fiction. Initially, the idea of terraforming Mars seemed more like fantasy than science. Over time, however, the concept has evolved from speculative fiction to a subject of rigorous scientific investigation. Advances in space exploration, particularly the Mars missions conducted by NASA and other space agencies, have provided valuable data about the planet's geology, climate, and potential resources. These missions have laid the groundwork for considering how we might transform Mars into a habitable world. Research suggests that Mars once had liquid water on its surface and a thicker atmosphere. This historical perspective gives scientists hope that it might be possible to recreate similar conditions, albeit with considerable effort and ingenuity. The dream of terraforming has shifted from a distant fantasy to a practical goal with defined steps and achievable milestones. Each discipline contributes to a comprehensive strategy for terraforming Mars, making the once impossible dream increasingly plausible. The first critical step in terraforming Mars is to warm up the planet. Currently, Mars has an average surface temperature of about -80 degrees Fahrenheit. To make it habitable, we need to significantly raise these temperatures. The most promising method for achieving this is by creating a greenhouse gas effect, similar to what occurs naturally on Earth. Greenhouse gases, such as carbon dioxide and methane, trap heat in a planet's atmosphere, preventing it from escaping into space. By artificially increasing the concentration of these gases on Mars, we can induce a warming effect. One proposed method involves releasing greenhouse gases from Mars's polar ice caps, which contain large amounts of frozen carbon dioxide. Another approach might involve manufacturing and deploying greenhouse gases directly into the Martian atmosphere. As the planet warms, the frozen carbon dioxide at the poles sublimates, releasing even more greenhouse gases and accelerating the warming process. The greenhouse gas effect remains the cornerstone of any terraforming strategy, laying the foundation for subsequent steps. Once Mars begins to warm, the next step involves introducing life forms that can survive and thrive in its harsh environment. Enter extremophiles, microorganisms that can endure extreme conditions on Earth. These hardy microbes, found in the depths of our oceans, hot springs, and the Arctic tundra, could be the pioneers of life on Mars. Extremophiles can perform various functions that aid in terraforming. For instance, some can metabolize minerals in the Martian soil, releasing oxygen as a byproduct. By deploying these microorganisms strategically, we can start altering the Martian ecosystem at a fundamental level. One particularly intriguing possibility is the use of cyanobacteria, which can photosynthesize and produce oxygen. Their ability to convert carbon dioxide into oxygen makes them invaluable allies in the quest to terraform Mars. The role of extremophiles is a vital step in transforming Mars, setting the stage for more complex life forms and eventually human colonization. As the Martian environment becomes more suitable for life, the focus shifts to generating oxygen, a crucial element for human survival. One of the most effective ways to achieve this is through photosynthesis, the process by which plants convert carbon dioxide and sunlight into oxygen and glucose. However, Mars's harsh conditions necessitate the genetic modification of plants to enhance their resilience. Genetic engineering allows scientists to create plants that can withstand the low temperatures, high radiation levels, and limited water availability on Mars. By incorporating genes from extremophiles or other hardy species, these modified plants could thrive and perform photosynthesis, gradually increasing the oxygen levels in the Martian atmosphere. As oxygen levels rise, the atmosphere becomes more breathable, and the potential for sustaining human life increases. Additionally, plants can contribute to the overall ecosystem by providing food, shelter, and other resources. Creating and maintaining large-scale greenhouses or open-air farms on Mars requires advanced technology and substantial resources. Photosynthesis and genetic modification represent a crucial step in the long journey to making Mars a new home for humanity. Water is essential for life, and finding a reliable source on Mars is one of the most significant challenges in terraforming. While Mars has polar ice caps and subsurface ice deposits, accessing and utilizing this water requires innovative solutions and advanced technology. One approach involves mining the ice and melting it for use. This process could be facilitated by robots or automated systems designed to extract and transport the water to where it is needed. Another possibility is tapping into underground aquifers, which recent research suggests may exist on Mars. Drilling and pumping systems would be necessary to access these hidden water reserves. In addition to extraction, water recycling and conservation will be paramount. Closed-loop systems, similar to those used on the International Space Station, could be implemented to ensure that water is reused efficiently. Ensuring a stable and abundant water supply is a foundational step in transforming Mars into a habitable world. Creating a livable atmosphere on Mars is one of the most complex and risky aspects of terraforming. Unlike Earth, Mars has a thin atmosphere composed mostly of carbon dioxide with very little oxygen or nitrogen. To sustain human life, we need to create a stable, breathable atmosphere that can protect against harmful radiation and support agriculture. One of the main challenges is preventing the newly introduced gases from escaping into space. Mars's lower gravity and lack of a magnetic field make it difficult to retain a thick atmosphere. Innovative solutions such as magnetic shields or artificial methods of increasing atmospheric pressure are being explored to address this issue. Another risk is the potential for drastic weather changes and natural disasters. The introduction of greenhouse gases and other terraforming efforts could lead to unpredictable climatic shifts. Careful monitoring and adaptive strategies will be necessary to mitigate these risks and ensure a stable environment. Achieving and maintaining this delicate balance requires ongoing research, monitoring, and adjustments. Despite these challenges, the potential for creating a new home on Mars drives the continued pursuit of this ambitious goal. Terraforming Mars is an unprecedented endeavor, fraught with challenges and uncertainties. The scientific, technological, and ethical obstacles are immense, and success is far from guaranteed. However, the potential benefits of creating a second home for humanity are too significant to ignore. One of the primary challenges is the sheer scale of the project. Transforming an entire planet requires immense resources, advanced technology, and international collaboration. The financial and logistical demands are daunting, and the timeline for achieving significant milestones extends over decades or even centuries. Ethical considerations also play a crucial role. The introduction of Earth-based life forms to Mars raises questions about contamination and the potential impact on any existing Martian ecosystems. Balancing the desire to explore and colonize Mars with the responsibility to preserve its natural state is a complex and ongoing debate. Continuous advancements and adaptations will be necessary to address unforeseen challenges and refine the approach. Despite these challenges and uncertainties, the pursuit of terraforming Mars represents the pinnacle of human ingenuity and ambition. As we continue to explore and develop new technologies, the dream of making Mars a new home for humanity becomes an increasingly tangible reality. In conclusion, the journey to terraform Mars by 2080 is a monumental undertaking that combines scientific innovation, technological advancement, and human determination. While the challenges are immense and the uncertainties significant, the potential rewards are equally profound. Transforming Mars into a habitable world offers the promise of a new frontier for humanity, ensuring our survival and inspiring future generations. The first steps in this ambitious endeavor involve warming the planet through the greenhouse gas effect, introducing microbial life to pave the way, and generating oxygen through photosynthesis and genetic modification. Accessing and utilizing water, maintaining a livable atmosphere, and addressing the complexities and risks are all crucial components of the process. The road ahead is long and fraught with obstacles, but the pursuit of terraforming Mars embodies the spirit of exploration and the boundless potential of human ingenuity. As we continue to push the boundaries of what is possible, the dream of making Mars our second home by 2080 becomes an inspiring and attainable goal. Let us embrace this journey with optimism and determination, knowing that the future of humanity may one day lie among the stars. From the moment we first looked up at the stars, we have been captivated by the mysteries of the universe. The twinkling lights in the night sky have always beckoned us, urging us to explore beyond our earthly confines. Humanity has yearned to explore the cosmos, driven by an insatiable curiosity and a desire to understand our place in the vast expanse of space. This yearning has led us to achieve remarkable feats, pushing the boundaries of what we once thought possible. We took our first tentative steps into space, launching spacecraft that carried brave astronauts beyond the safety of our planet. These pioneers ventured into the unknown, paving the way for future generations. Landing on the moon was a monumental achievement, a testament to human ingenuity and determination. The iconic image of an astronaut planting a flag on the lunar surface symbolizes our relentless pursuit of knowledge and exploration. Now a new frontier awaits us, Mars. The red planet has long captured our imagination, and with each passing year, we inch closer to making it our next home. The surface of Mars, with its rugged terrain and mysterious landscapes, holds the promise of new discoveries and endless possibilities. By 2025, the dream of colonizing Mars will no longer be a dream, but a reality. Futuristic cities will rise from the Martian soil, bustling with human activity and greenery. These colonies will be a testament to our ability to adapt and thrive in even the harshest environments. This is not just a technological feat, but a testament to the indomitable spirit of exploration that resides within us. Engineers and scientists are working tirelessly, overcoming countless challenges to make this vision a reality. Their dedication and innovation are the driving forces behind this monumental endeavor. We stand on the cusp of a new era, one where humanity becomes an interplanetary species. The establishment of human settlements on Mars will mark the beginning of a new chapter in our history, one that will redefine our understanding of life and our place in the universe. The journey ahead will be challenging, but the rewards will be immeasurable. As we venture into the unknown, we will uncover new knowledge, develop new technologies, and forge a path for future generations to follow. The spirit of exploration will continue to drive us forward, inspiring us to reach for the stars and beyond. Today, Mars is a harsh and unforgiving world. Its surface is a desolate expanse of red dust and rocks, devoid of life as we know it. The air is thin and unbreathable, the temperatures extreme. But beneath this stark exterior lies the potential for something extraordinary. Mars possesses all the elements necessary for life: water ice locked beneath its surface, carbon dioxide in its atmosphere, and sunlight to power it all. These are the building blocks of a habitable world, a world waiting to be awakened. The transformation of Mars will be a monumental undertaking, a feat of engineering and ingenuity on a planetary scale. The key to this transformation is terraforming, the process of altering Mars's environment to make it more Earth-like. This is not about conquering Mars, but about working with its natural processes to unlock its hidden potential. Imagine vast solar mirrors placed in orbit, focusing the sun's energy onto the Martian polar caps, releasing trapped carbon dioxide into the atmosphere. This in turn will trigger a greenhouse effect, warming the planet and thickening the atmosphere. As the Martian atmosphere thickens, the planet will begin to transform. Temperatures will rise, allowing liquid water to flow once more on the surface. The once thin air will become denser, and with the help of genetically engineered microorganisms, we will seed the atmosphere with oxygen. This is the alchemy of terraforming, transforming a barren world into a vibrant living planet. It's a gradual process, unfolding over generations, yet each step brings us closer to the dream of a second home for humanity. Section 5, Water, the elixir of life. Water is, the lifeblood of any habitable planet, and Mars holds the promise of abundant water resources. Beneath the surface, vast reserves of ice await, remnants of a time when rivers may have flowed on Mars. This water, once unlocked, will be the lifeblood of our Martian colonies. We will build underground habitats, shielded from the harsh radiation on the surface. These habitats will utilize hydroponics and vertical farming techniques to grow food, creating self-sustaining ecosystems. Section 6. Martian Pioneers, Building a New Home. As we embark on this monumental journey, we are not just building structures, we are laying the foundation for a new chapter in human history. The first humans to set foot on Mars will be pioneers in the truest sense of the word. These brave souls will be the vanguard of humanity's expansion into the cosmos, taking the initial steps on a planet that has fascinated us for centuries. They will be explorers, scientists, engineers, and visionaries, driven by an insatiable curiosity and a pioneering spirit. Their mission will be multifaceted, involving not just survival, but the establishment of a thriving community. They will conduct groundbreaking research, develop new technologies, and create a sustainable way of life on this distant world. They will face challenges unimaginable to those of us on Earth, but their courage and resilience will pave the way for future generations. From the harsh Martian weather to the complexities of building habitats in an alien environment, every obstacle will be a testament to human ingenuity and determination. Life on Mars will be different, demanding adaptability and innovation. The habitats will be designed to support human life in an environment that is both hostile and awe-inspiring. Greenhouses will provide fresh food, and living quarters will be adaptable to the changing needs of the inhabitants. We will learn to live in harmony with our new environment, harnessing its resources sustainably and preserving its unique beauty. The goal will be to create a self-sustaining colony that respects the Martian landscape while utilizing its resources efficiently. This balance will be crucial for the long-term success of human life on Mars, ensuring that we do not repeat the mistakes of our past on Earth. The social fabric of the Martian colony will be just as important as its physical infrastructure. Community activities, cultural events, and educational programs will be essential in fostering a sense of belonging and purpose among the inhabitants. Children born on Mars will grow up with a unique perspective, blending the pioneering spirit of their parents with the traditions and knowledge of Earth. Advanced medical facilities will be crucial in addressing the health challenges posed by the Martian environment. Research will focus on understanding the effects of reduced gravity, radiation, and isolation on the human body, leading to medical advancements that could benefit all of humanity. Transportation systems will evolve to meet the needs of the growing colony. Rovers and other vehicles will become more advanced, facilitating exploration and the transport of resources. Infrastructure development will be a continuous process, adapting to the expanding needs of the community. Celebrations and symbolic moments will mark the milestones of our journey. Looking back at Earth from Mars, we will be reminded of our shared origins and the incredible journey that brought us to this new frontier. Each achievement will be a step forward in the grand adventure of human exploration and settlement in the cosmos. Section 7. A new branch of humanity. As more humans make the journey to Mars, a new chapter in human history will begin to unfold. We will establish thriving communities, connected by high-speed transportation networks. We will build schools, hospitals, and cultural centers, fostering a new Martian identity while remaining connected to our earthly heritage. This is not about abandoning Earth, but about ensuring the survival of our species. By expanding into space, we safeguard humanity against the possibility of a catastrophic event on our home planet. Section 8. The Martian Ethos. The colonization of Mars presents us with a unique opportunity to re-examine our values and create a new societal model. We will have the chance to build a society based on sustainability, collaboration, and scientific curiosity. This new Martian ethos will be one of exploration and discovery, a society that values knowledge and innovation. It will be a society that embraces diversity and strives for equality for all its citizens. Section 9. A universe of possibilities. The successful colonization of Mars will be a defining moment in human history, a milestone that will forever change the way we perceive our place in the universe. Imagine a world where humans live and thrive on another planet, where the red soil of Mars becomes a new home for generations to come. This achievement will not only be a testament to our technological prowess, but also to our unyielding spirit of adventure and discovery. It will be a testament to our ingenuity and our unquenchable thirst for exploration. The journey to Mars will require unprecedented collaboration and innovation, bringing together the brightest minds from around the globe. Engineers, scientists, and visionaries will work tirelessly to overcome the challenges of interplanetary travel, creating new technologies and solutions that will benefit all of humanity. It will usher in a new era of space exploration, inspiring us to reach for even greater heights. The establishment of a human presence on Mars will serve as a stepping stone for future missions to more distant worlds. It will ignite a renewed passion for space exploration, encouraging the next generation of explorers to dream big and aim high. Beyond Mars lies a universe of possibilities, an endless expanse of stars, planets, and galaxies waiting to be discovered. Each new discovery will expand our understanding of the cosmos and our place within it. The mysteries of the universe are vast and profound, and the colonization of Mars is just the beginning of our quest to unravel them. With countless stars and planets waiting to be explored, the potential for new discoveries is limitless. From the search for extraterrestrial life to the study of distant celestial phenomena, the opportunities for scientific advancement are boundless. Each new mission will bring us closer to answering some of the most fundamental questions about the nature of the universe and our place in it. The colonization of Mars is not the end of our journey, but the beginning of a grand adventure that will shape the future of humanity for millennia to come. As we venture further into the cosmos, we will continue to push the boundaries of what is possible, driven by our insatiable curiosity and desire to explore the unknown. This grand adventure will inspire future generations to look to the stars with wonder and ambition, knowing that the universe is within their reach. The legacy of our efforts today will be felt for centuries, as humanity continues to explore, innovate, and thrive in the vast expanse of space. The future is bright, and the universe is ours to explore.